Hi guys, today will be day one of factoring. We're going to be talking about trinomials, difference of squares, GCF, and grouping. These are topics that we've actually covered already in Algebra 2, but we're going to review them today so that we can move forward into more complex factoring. Eventually the goal that we're going to be doing is we are going to be factoring with trig ratios, so sine, cosine, tangent, and secant. And that'll sort of prepare us for Chapter 3, where when we do trig proofs, it's going to be important to know how to factor. So let's begin. First method, GCF. Okay, this is like divide everything by. And you need to divide by the same number. So if you are able to do this red part in your head, that's great. I like to write it out. I know that there's always the x's we want to cancel out at the end. Okay, so our GCF will be x, which needs to show up in your answer. And then we have x plus 5, because that's what remains when we divide each of these terms. The next one, we can divide by numbers sometimes as well. So these numbers can both be divided by 2, and they can both be divided by x. And so our GCF is 2x. We need to make sure that shows up outside. And then 2x squared divided by 2 is x. Negative 16 divided by 2 is 8. And the x's always cancel out. Okay, the entire goal of factoring is to make sure this last term has no x's. So let's keep going. One thing to be aware of is that if you start with a term that is negative, then you actually want to make sure you divide by a negative. So these can both be divided by negative 5, and these negatives need to cancel out. Okay, and then notice there's an x squared at the end, so these x squareds need to cancel out. So my GCF is negative 5x squared, and then what's left is x minus, and be careful here, the 5's don't just cancel out. 5 divided by 5 is 1. And how you check each of these answers is if you distributed, then each of the products, or what you distribute, becomes the same as what we started with. This is just backwards division. Or sorry, it's division, which is backwards multiplication. Okay, so I want you to pause the video and try 1, 2, and 3. I'll give you all the answers for them at the end of the page so you can check them all at the same time. Example 2a. When we have a trinomial, that means we have 3 terms, 1, 2, and 3, but we have a equals to 1. We can use something called the x method, where you multiply to c and you add to b. Okay. So this is a, which is 1, b, and c. And so you can think of it as I need 2 numbers that multiply to 24, which is my c, and add to 11. Okay, and you have to be able to sort of scan through the options to figure out that the numbers will be 8 and 3. Now what if you don't know your times tables very well? Well, then I want you to be able to list out like what multiplies to 24. Then you just start with 1 times 24 and you use your calculator, okay? And then we start with 2's, and you can use your calculator again. So let me pull my calculator out, right? And check like 24 divided by 2 is 12, and like get an answer of 12. Then you try 3. 24 divided by 3 is 8. And that's enough for us because we know it's 3 and 8. But if you kept going, then you would get 4 and 6. 5 doesn't divide, and then do you see how if we continue to 6, it starts to repeat, so we don't need to list those again. So if you're unable to just like know by looking at these numbers, I want you to list out your numbers and then pick the appropriate numbers. Final answer will just be x plus 8 and x plus 3. Okay. So this one we want numbers that multiply to 18 and add to negative 9. Okay, so if I list out my 18s, 1 times 18, 2 times 9, 3 times 6, now we have to think about signs. Okay, so 3 plus 6 adds up to positive 9, but we want negative. And a negative 3 times a negative 6 gives me positive 18. It does not matter which number you write first, because 3 times 6 is the same as 6 times 3. We're going to get a little bit more complex now, right? So we want two numbers that multiply to 8y squared and add to 2xy. So if you think about this now, the reason why we've had x and x is because we've been multiplying to x squared, right? So here we still have x and x, but if we want to multiply to 8y squared, then we need like a number and a y as well, right? So this is going to break up to what multiplies to negative 8 and adds to 2. So let's see, we have 1 times 8, 2 times 4. Those are my only two options, and because it's a negative, I want to make one of these negative, one of them positive. The bigger number always matches the sign in the middle. So the 4 will be positive, and the 2 will be negative. Now, if I want 8y squared, then I know I'm going to need x's in the first one, and then I'll have y's in the second one. And then I'll have negative 2, so x minus 2y, and x plus 4y. And now if we check it, x times x is x squared, x times 4y is 4xy, minus 2xy, minus 8y squared. So when you have y squared at the end, you're just going to split your y's and have 2 y's at the end. Okay. 3 for you to try. Careful of your signs. Okay, I'll show answers at the end of all of my examples. Okay, let's do factoring using the difference of squares. So difference means subtraction, and squares means perfect squares. Perfect squares are like 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. Okay. The thing you want to remember though is it needs to be a difference, because our goal is to get two numbers that multiply to negative 16. And notice there's nothing in the middle, which means it adds to 0. And the only way we can make that happen if we used our x is if I had one positive number and one negative number, right? And they always have to be the same. So, but different signs. So 4 times negative 4 has to be negative 16. It will never be positive 16, because then 4 plus 4 is 8. So this has to be a negative, and it has to be a perfect square. Once you establish that you have perfect square, negative, perfect square, then you can just split it. X times x, right? And 4 times negative 4. So eventually you won't need to show this. What you'll have is just x minus or plus 4, x minus 4. Okay. The next one, if you split it, is 2x and 2x, and then 3 and 3. So it'll be 2x plus 3, 2x minus 3. Same idea, okay? 1 times 1. And then this is 13x times 13x. 1 negative, 1 positive. Okay, so whatever order it is in, that's the order that needs to show up here, right? So if there's a negative 169, then it needs to be negative 13 times a positive 13. Okay. These are for you to try. Ooh, I should probably do one more, right, just to show you what happens with bigger exponents. We want to divide them perfectly evenly. So this will be x to the 4th times x to the 4th. If they're not divided evenly perfectly here, then it will not add or subtract to 0. Okay. So this will be 7y and 7y. Sorry, 1 negative, 1 positive. Okay, so just make sure your exponents get split evenly as well. So this will be x to the 4th plus 7y, x to the 4th minus 7y. Okay, now you're ready to try these two bigger exponent numbers. Factoring using GCF and X method and difference of squares. So what makes factoring more difficult is that eventually, well, what makes it difficult is like there's so many different methods, and right now it's nice and easy when we do 6 of the same problem. Eventually you're going to have it all mixed up, okay, and you're going to have to establish what do we do based on what you see. And the first thing you should always try is GCF, because GCF makes numbers smaller, right? So you want to divide if possible. So let's take a moment. We're going to take a GCF of everything can be divided by 2. You see that's my smallest number. So I can't divide by 4, because if I divided by 4, then I would get a fraction here. Okay. This one has 2 x's, 1 x, but no x. But if I look at this last one, remember, we can check, do they all have y squareds? I think they do. So at this point, I have my GCF of 2y squared. It'll be 12x squared plus 1xy. Oh, no y's, sorry. And then minus 6. Okay, and no y's left. Uh-oh. I think in theory, I wanted this to be a 1. Sorry about that. Can we change this to 2 instead of 24? Okay, because I wanted to show you something. So if this canceled out, then I have 1x squared. Thank you. So because of this, then I can see that here for this trinomial, we can do another x method. What multiplies to -6 and adds to 1, right? And that's going to be 3 and -2. So then I can keep going. 2y squared, then I'll have x plus 3, because the bigger number matches the one in the middle, with a sign in the middle, and then x minus 2. Okay, so it's a combination of GCF and one of our other methods, X method. Okay, let's keep going here. Let's see, we can divide both of these by 3. Okay, they both have 1 y. This one doesn't have an x, so I can only divide by y's. That gives me 3y, and then I have x squared left, and then minus 25y squared. And we can see that these are both perfect squares. Okay, so I'm going to just show work like that, and that'll be 3y, and then my 2 parentheses will be x, and -5y, and positive 5y. Let's do one more. This will be divided by 5, because 5, 5, and 30 can be divided by 5. They do not all have an x, but they all have 2 y's. Oh, this one's similar. Okay, this one's for you to try. Okay, so once you do this, you can simplify and make things look like what we can do with an x method or a difference of squares. Just briefly, factoring is all about practice, because when someone shows you what numbers to use, it's really easy to understand what's going on, but it doesn't mean that you can do it yourself. With your negatives on the outside, the x on the inside needs to be positive. So if there's a negative in front, we divide by a negative. Okay. This one, make sure that you write this down. X minus 5y. If there's 2 of them that are the same, rather than writing it twice, we can skip this step and jump straight to x minus 5y squared. Okay, this is the simplest form. Here's our 2 factors. Split your exponents in half, and in half, and in half, and in half. Over here, 11 looks like you can't keep going, but there actually is a method for this. We just haven't learned it quite yet. We will soon. It's going to be a times c, because we have a number in front. That changes things. Okay, so we don't actually want 2 numbers that multiply to 10 and add to 11. there are no numbers that multiply to negative 10 and add to negative 11. Let's keep going here. This one, I don't know if I've made explicit enough, but notice that x to the fourth, x squared, like these are cut in half. So what that means is if I split my x to the fourth in half, then when we add them, we're going to get negative 4x squared. You see how if I distribute, it's going to be x to the fourth power, and then 2x squared, and then minus 6x squared, right? And the last one has no exponents. This one you can divide by x to the eighth, y to the eighth, which gives you a perfect square right here, even though there's no numbers, right? They're still perfect squares. Okay, 2 more on the back. We're going to do something called factor by grouping, and then we're going to talk about how factor by grouping helps us when a is greater than 1. So, factor by grouping only works when you have 4 terms in the polynomial. Okay? And this only works for some expressions with 4 terms in the polynomial. So the first thing we're going to do is create 2 groups of binomials. And I like to call this method the double GCF. Because you're going to take the GCF of the first 2, which is 5x squared, positive because the first number is positive, but x squared because this last number is x squared, right? And then these 2 take the GCF, which is 3 and 3. Okay, I don't care about the negative 6. I only care about the positive 3 in front. Okay, so now we have 5x squared and 3, and on the inside of our 2 GCF problems, we are left with our remaining terms. 5 divided by 5 is 1, x cubed divided by x squared is x, negative 10 divided by 5 is negative 2, and the x squareds cancel out, always, right? 3 divided by 3 is 1x, negative 6 divided by 3 is negative 2. Okay. This is not a coincidence. What is left inside both parentheses must be the same, or you cannot factor by grouping, or you're wrong. Okay, it's one or the other. Okay, because in order for us to write our final answer, you have to write the GCF and GCF together in one parentheses, and then we write what's left in the other. Okay. So in order for us to write what's left together, it needs to be the same. So this will be 5x squared plus 3. Those are my GCFs. And then here will be 1x minus 2. And we're done. Do not put a squared on this 1x minus 2. Okay, because how the 2 of them show up is that when I distribute, you see how distributing 5x squared to 1x and negative 2 gives me that. And then if I distribute this one, it gives me that one. So we use them both when we distribute, but you don't need to put a squared. Okay? So let's do another one. Double GCF. Minus 1, minus 1. Okay. So I'll have negative x squared and minus 1 on the outside of my 2 parentheses. What's left will be x plus 1 and x plus 1. Oh, sorry, I don't know why I wrote a negative. There we go. Okay, so now what we put together is x squared minus 1 and x plus 1. Factoring is tricky because there's always more things you need to check for, so even when you get to your final answer, you need to check that you cannot GCF, factor by the x method, or difference of squares. Do you see how this is a difference of squares? It's 1 times 1 and x times x. Okay? So our final answer here is x minus 1, x plus 1 because of the red part, and then I bring down my x plus 1 from the blue. Okay? And we know that we want to simplify this together, so our final answer is going to be x minus 1, x plus 1 squared. And so oftentimes in factoring by grouping, there's this extra step that you need to take, either GCF if you can, or difference of squares if you can. I I have 3 for you guys to try here. Okay. I think I put it first so that everyone would have to try that one. Notice here, once I cover this, everything's covered. 2 and 2 are divisible by 2, so you have to take out the GCF, and once you do that, there's a difference of perfect squares because there's a minus and perfect square. So we can keep going here. This positive is not a difference of perfect squares, so please make sure you don't keep going when there's a positive, right? Because you need a negative for difference. And this last one was pretty straightforward, nothing special. Okay. Let's do our last example. Okay. So this one's very similar to A times C. It's similar to the double GCF, but you're going to use an X method with A times C on top and B on the bottom because our trinomial now has A, B, and C. So we're going to do a small one over here. A times C is 5 times 2, which is 10. 11 goes on the bottom as usual. Okay, so what multiplies to 10 and adds to 11? That's going to be 10 times 1. And what you're going to do is split the middle. Okay, so we have to split because we don't have 4 terms, but our goal is to get 4 terms so that we can double GCF after I should write this in, split the middle. Okay. So instead of 11x, I'm going to write 10x plus 1x. And then we'll bring down the 2, and we'll bring down the 5x squared. Okay. Now we're going to do exactly the same thing and double GCF. And if you have picked the right numbers, this will work out perfectly, where the parentheses will have the same terms inside. If you can't divide by anything, 1 is perfectly acceptable. So we'll have 5x, x plus 2, and then plus 1, x plus 2. I think some of you guys are probably at the point where you feel like you could skip this and skip this line and jump straight to 5x plus 1 and then x plus 2. And that's fine, as long as you're aware that your second parentheses are the same. Okay, so I don't need this step necessarily if you want to skip and go straight to here. Okay. At this point, this is exactly the same, just with negative numbers, and the only thing I want you to remind yourself is if you have a negative number, well, let me show you this one, because students will ask me, A times C is 4 times 3, or negative 3, which is negative 12, and then add to negative 4. So sometimes students will ask, if I choose negative 6 and positive 2, okay, 4 and 6 doesn't have an easy GCF. Do you guys see that? But I could also switch it and go negative 2x, positive 2x minus 6x minus 3. And if I do it this way, I think this is a more visually easy to see GCF, which is 2x and 2x. And negative 3 and negative 3. Okay? So, a few more for you to try. And I'll pause my video and show you answers in just a second, but I will only show you final answers here. Okay, here are the last 3 answers for you to check. Notice that this one had a GCF first, which makes my number significantly smaller in my final answer. And because there's 2x minus 1s, I can combine them into 2x minus 1 squared. There's homework for you to practice. The numbers start getting really big, so do not give up.